In this video, we'll look at trends in the periodic table. And trend just means patterns that you observe as you go across a period or down a group. There are three trends that you are expected to know for Chem 3.4. The first one is atomic and ionic radius or radii. Ionization energy and electronegativity is the third trend. For all three, you will need to use the periodic table, which is part of your resource booklet. So you pull out the periodic table and keep that in front of you, and then you can start answering the question. Before we start, if you have not got a definition for the three trends, it would be a good time to pause the video and copy the definitions down. Most often in the exams, I've seen the examiner ask for a definition of ionization energy or a definition of electronegativity. However, it's also good to know what is atomic radius and how we measure atomic radius. The definition says is the atomic radius of a metal is half the distance between the nuclei in two adjacent atoms. And for elements that exist as diatomic molecules, the atomic radius is half the distance between the nuclei of the two atoms in that molecule. So we've dealt with the definition. Now let's look at the trend. So I'm going to first deal with atomic and atomic radius, and then I'll look at ionic radius. All right. So if you remember from your previous work that we've done, as you go from left to right on the periodic table, we call that as a period. And as you go from the top to the bottom of a column, we call that as a group. All right. And the trend is that atomic radius decreases across a period. So when you go from left to right in a period, the atomic radius, which I'm just using A and R, and I'm using the downward arrow to show that it decreases. On the other hand, if you look at atomic radius of elements or atoms of elements in a particular group, as you go down the group, the atomic radius actually increases. So the next part of the task is to actually explain why it decreases across a period or increases down a group. Now, if you're a visual learner, you could also keep this picture in mind. As it is very obvious in this picture, as you're going down the group, the atomic radius is actually increasing, and you can see the size of the atom actually increases. Whereas as you go across the period, you can see the atomic radius decreasing and the size of the atom itself decreasing slightly. Now, an explanation for this can be given in the following is in this slide, and you always start by discussing the atomic number. So if you're asked to discuss the trend of atomic radius and the focus is across a period, then here's how you answer it. Start by talking about the atomic number and how it increases across a period. Next, you also want to say that when you have atomic number increasing, atomic number gives you the number of electrons, so the number of electrons also increases. However, as the number of electrons increases in the same period, the extra electrons are being added into the same energy level. And so as a result of adding them into the same energy level, you will the electrons will experience electron repulsion. Repulsion, it just means they push away. All right, so the next thing you want to state in your answer is that, so you've dealt with the number of electrons. Now you also want to deal with the nucleus and what's happening there. So you state that the nuclear charge is a phrase for the number of positive protons in the nucleus, and that increases across a period. So if we go back a few slides and you look at the periodic table, if we consider this row, period number 2, lithium all the way down to neon, all right? If you look at lithium, it has an atomic number of 3 and neon has an atomic number of 10. That means lithium has 3 positive protons and it has 3 negative electrons. On the other hand, as you go to the right of that period, neon has 10 positive protons and it also has 10 negative electrons. So that's what's happening with neon. So you can clearly see that there is an increase in the nuclear charge. Nuclear charge means the number of positive protons. 3 in lithium, but across the period, by the time you reach neon, it is 10 protons. So we say the nuclear charge has increased. Now you also have the number of electrons increasing from 3 to 10. And so as you add more electrons, the important thing to remember is that they're being added into the same energy levels. So that's our explanation for nuclear charge. So what happens is this causes the nucleus, what it does is because it's positive, it will attract the negative valence electron, pulling the valence electron closer to the nucleus. This effect of increasing nuclear charge outweighs the effect of electron repulsion, and hence the atomic radius, it decreases across the group. All right, so we'll just go through this trend again. If you're asked to discuss atomic radius across a period, start with the atomic number, link that to the number of electrons, and that the number of electrons are increasing, and each additional electron is being added into the same energy level. So that leads to electron-electron repulsion. However, at the same time, you're also increasing the number of positive protons in the nucleus as you go across the period. This means the nuclear charge is increasing. And now that the nucleus is, because it's getting more and more positive, the electrostatic means attraction between something that's positively charged and something that's negatively charged. That electrostatic attraction between the positive nucleus and the valence electron increases across the period, and because of that, it pulls the valence electron closer to itself. As a result, this feature or this factor outweighs electron-electron repulsion, and hence atomic radius decreases across a period. Now, if you're asked to give the same explanation down a group, what you need to do is you'd start with the same idea of the atomic number. You'd start with by saying atomic number increases down a group, and then you'll state that the nuclear charge, which is the number of positive protons, also increases down the group. Right? And then for the next part, what you need to talk about is the electrons. Number of electrons also increase as you go down a group. However, the difference is when you're going across a period, they were being added to the same energy level, but here the electrons are added to successive energy levels. That means they fill up one energy level, then they go to the next one that's a little higher, etc. And this means that the valence electron is now further and further away from the electrostatic attraction of the positive nucleus. So what impact does that have? The inner electrons, they shield the valence electron from the attraction of the nucleus, and as a result, atomic radius increases as you go down the group. Why? Because the nucleus would have been able to attract its valence electron, but you have a problem. One is that the valence electron is now further and further away as more and more electrons are added in. And the second feature is that the inner electrons, the ones that are in the completely filled inner energy levels, they shield the valence electron from the attraction of the nucleus, and so that attractive force of the nucleus over that valence electron is not as pronounced, and as a result atomic radius increases down the group. If you haven't got this answer, pause the video and copy this down. The next idea we need to look at is ionic radius. Now there are two types of ions, the ones that metals form where they lose an electron and they form positive ions. And the other type is the non-metals, and what non-metals do is they gain electrons so they can have a completely filled outer shell, and as a result they will form negative ions. So if you're looking at positive ions and you're looking at the trend down a group, it increases. Across a period, it decreases. Again, if you're looking at negative ions, the trend is down a group, the ionic radius increases. Across a period, ionic radius decreases. Now let's look at an explanation for why that is. If you're asked to compare the radius of an atom with its own positive ion, then here's the answer frame. You would start by saying the atom and its ion, they have the same number of protons, so the nuclear charge is exactly the same. But when that atom loses, because to form a positive ion, it would have had to lose an electron. So when it loses and you write down how many valence electrons, either one valence electron if it was in group 1, two valence electrons, group 2, etc. So you put the number of valence electrons there, and what it results in is, so they lose the valence electrons to form the whatever the ion. So for example, if we take sodium atom and sodium ion, I would fill up sodium atom and its ion have the same number of protons, so that nuclear charge is the same. But when the sodium atom loses one valence electron, how do we know that? Sodium is in group 1, so it will lose one valence electron to form the Na plus. How do we know that? If it loses one electron, the charge on it is going to be plus 1. And losing that one valence electron, it actually lost an entire energy level. So it results in fewer shells. This results in greater attraction between the nucleus and the valence electron. So the outer electrons are now pulled closer to the nucleus, and that results in the positive ion, any positive ion, in this case the Na plus ion, having a smaller radius than the Na atom. So here's how you discuss the radius for a positive ion. Now let's look at how you do the same explanation for a negative ion. If you were asked to compare the radius of an atom with its negative ion, here's how you'd start it. So let's take an example of chlorine and Cl minus and the chloride ion. So you would say chlorine atom and the chloride ion have the same number of protons. Nothing has changed in the nucleus. Remember, when you're forming an ion, it's only the number of electrons that change. So that's why we start by saying both these chemical species, they have the same number of protons and the same nuclear charge. But when the chlorine atom gains one electron to form the Cl minus ion, there is an increased electron-electron repulsion. Why? Because you're adding that, that electron that it gained goes into the energy level where there are already some existing electrons. So as a result, electron, which is negatively charged, pushes away the other electron, which is negatively charged. So because of this, as a result, the electrons move further apart, and therefore the ion, the negative ion, which is Cl minus ion, has a larger radius than the Cl atom. So just reviewing how you'd write the answer for a negative ion, compare it. So you actually talk about what is similar. The atom and its ion have the same number of protons, same nuclear charge, but then something is different. The atom has now gained one electron. By gaining the electron, it has added to an energy level that already had electrons, and so that results in electron-electron repulsion. Repulsion means to push away, so the electrons move further apart, and therefore as a result ionic radius for a negative ion increases, or the ionic radius for a negative ion is larger than the radius of its own atom. Alright, so I hope this video was useful, and I hope you will pause and make notes wherever you need to. In the next section, there's just an exam question which I'll quickly leave on the screen for you to have a look at.